Thank you very much for giving me the opportunity to introduce this freshly funded STN. So as you said, I won't have a lot of activity to introduce, but I'm sorry, but I will give an overview and of the STN. So I would like to start with thanking the co-organizers. We are quite a few, and we span, as probably all the STN, a variety of systems from plants to animal and methods, and also environment from terrestrial to aquatic. So dispersal and mating system. Dispersal and mating systems, they are a suite of physiological, morphological, behavioral and demographic traits. And in particular, dispersal has been defined as any individual movement potentially leading to gene flow across space, while mating system can be defined as this general strategy employed in mate choice and acquisition, and which shaped the gene flow across time. So because of this fundamental role in shaping spatiotemporal gene flow, dispersal and mating system are fundamental for species evolutionary ecology and population viability. But they are also fundamental because they affect a number of ecological and evolutionary processes. So through their influence on gene flow, space and times, they shape the relatedness structure within and among population, and thereby the level of inbreeding. And therefore, they affect the distribution and maintenance of genetic variation, both within and between population. But they can also directly or indirectly affect intraspecific competition, population viability, and spatial processes, such as, for example, metapopulation dynamics and ranges function. Further, they can affect the opportunity and operation of sexual selection and sexual conflict and sociality. And as Franjo correctly said, they can also affect the modality of speciation. Importantly, not only dispersal and mating system shape this thereby creating ecological and evolutionary feedbacks that can shape the dispersal and mating system syndromes that we might observe in nature. Now, dispersal and mating system have been widely studied, and we have a very healthy community of research that both study dispersal and both study mating system. But historically, these two fields have been quite separate, with quite a little cross-talking between each other. And this is not to say that nobody has ever thought about the link between dispersal and mating system. And in fact, we have quite a few long-standing hypotheses of dispersal and mating system evolutionary syndromes. For example, a lot of attention has been given to inbreeding and its cost. Inbreeding depression is shaping dispersal and mating system syndrome, especially in plants. So for one example is that we have two competing syndromes that, or alternative syndromes that we might expect to see, where either individuals disperse and therefore outcross, or individuals do not disperse and therefore inbreed. And this is, I'm going to put my pointer. This is one of the few examples where we have actually a model, a theoretical model, where both dispersal and mating system traits jointly evolve. And this was published already in 2009 by Sheptu and Massot, where with a model that was varying pollinator availability and cost of dispersal and cost of inbreeding, they show that these two alternative strategy may be expected. However, historically, we also have another, if you wish, competing hypothesis, which is the Baker's law, which was proposed by Baker and Stebes already in the 50s. And I said competing because it's commonly thought as an association between long-distance dispersal and inbreeding or selfing. But actually, in a review from John Pannell and colleagues revised or revisited this law and shows how it perhaps not competing hypothesis, but is more complementary to the non-dispersing inbreeding syndrome. And this becomes clear when we define where they define the Baker's laws as an enrichment of a capacity of uniparental reproduction in species for which colonization brings about mate limitation during the establishment phase as new population that may follow long-distance dispersal. And so we can see then that Baker's law, or this is association between dispersal and uniparental reproduction, can be important or observed in particular circumstances such as colonization of oceanic island, range expansion, or metapopulation with a higher turnover rate. For animals, we also have kind of established hypothesis that links the bias, the sex bias in dispersal, so where only one sex or one sex preferentially disperse with animal mating system. And this was proposed by Greenwood in 1980, where very generally he concluded that we should expect a female bias in dispersal for monogamous birds and a male bias in dispersal for polygynous mammals. However, this hypothesis never completely satisfied the community because yes, it is a broad pattern, but there are a lot of exceptions. And in fact, in this review in 2016, Truchet and colleagues showed a mild, this was a meta-analysis, sorry, not a review, a meta-analysis showed mild support for the Greenwood hypothesis. And interesting, Shang He, who's also co-organizer of the network, and Anna Coco published a review of the theory on evolution of sex-biased dispersal. And apart from very nicely illustrating that there are a number of ecological evolutionary drivers of sex-biased dispersal, they highlighted the lack of theoretical formal model where the sex-biased dispersal and the mating system evolves. So this is just a few examples to show how, in fact, there seems to be a lack of formal model and synthetic theory. So very few models consider the joint evolution of dispersal and mating system traits and the ecological drivers that can lead then to spatial variation and their variation and the effect of spatial processes, and therefore broadly considering these eco-evolutionary feedbacks that I mentioned before. When you start looking into this, you also realize that there is a lack of data. And so when, especially data that would allow us to establish the covariation between dispersal and mating system within a species, and then the variation, for example, across the species range. So this depicts a picture of quite broad knowledge gaps. And here I just listed a few questions, but there could be many more. And for example, what spatial patterns of covariation we might expect in dispersal mating system syndrome, how do they vary across taxa, across environments, and also therefore how then environmental change will impact this syndrome, and what are the consequences for population viability and so forth. So in this context of gaps of knowledge between these two fields, the idea for this special topic network was born. And this is just a schematic illustration that we try to put together to show, let's say, the domain that the initially the STN wants to address. So of course we have this question of joint evolution of dispersal and mating system under different circumstances, but we also have this axis of variation with the plant community on one side, the animal community on one side, and here is to show that traditionally the plant community focused very much on the role of inbreeding and evolution of selfing, while perhaps the animal community has been more focused on sexual selection. Now, whether these drivers are more important in the two groups or whether this is historical contingency is still to be determined. We also have a much less explored axis of variation between terrestrial and aquatic environment, where most of the examples come from terrestrial environment and very little from the aquatic, where, for example, we could think where the medium of dispersal could affect the type of syndrome that we get in aquatic environment as opposed to terrestrial environment. And these little balls are just the initial of the co-organizer, and we try to put together theoretician and empiricists to populate this domain, and we are starting to populate the network more across this domain with participants, of course. And so the main objective of the network is kind of to reduce this kind of divide between the two fields and start getting at the ecological and evolutionary feedbacks between dispersal and mating system. And as probably all the networks, we have the aim to foster new synthesis, new research avenues, and new collaboration in this research space, and specifically to identify theoretical knowledge gaps and starting building models that take into account their joint evolution for a start and the eco-evolutionary feedbacks with different ecological processes. And for sure to provide conceptual advantage, but also to hopefully provide empirically testable prediction. And this is also a theme that we worked very well in the previous talk and also in other talk. One aim is to collate existing data and identify data gaps. So we would like as well to create a public and easy searchable database. And so we ask contribution for the community as well. We are not just as advanced as the previous STN. And hopefully with this exercise, we can expose and start filling the gaps specifically within species variation for dispersal and mating system traits. And hopefully with theoretical and empirical advances, we can start addressing question of dispersal mating system covariation in space, across taxa, and across environment. And with that, I just finish with the call of joining us if you are interested. We have a very new website the PhD students has kindly and very professionally put together, and here's the QR code for that. So we are looking, as I said, for people that span this domain: plants, animal, aquatic, terrestrial. You don't need to have thought before about the link between dispersal and mating system, but if you're interested in dispersal and mating system, and just linking the two together, just join us. And we are interested, of course, in ECRs and students that would like to lead activities, and we can support them. And last thing I can say is watch this space, stay tuned. We will have online seminar discussion series coming up, and we are planning for a 3-day workshop with a mix of kind of conference and training style before ESEB 2025 in Barcelona, and there will be more activities coming up. Thank you.